To start off the video, I'll ask the following question. How do geographers present data? We can present data in a variety of ways, but most often we associate maps with geography. However, we can use graphs such as a bubble graph here to represent data by attributing each bubble to a country. We can even combine the two and put graphs onto maps, such as putting a pie graph onto this map to show the population share by age. But what are maps even? How do we define what a map is? I have two definitions here, one more complex and one simple. A definition introduced by Campbell describes a map as a concrete or abstract representation of the features that occur on or near the surface of the Earth or other celestial bodies. Note that he says other celestial bodies, which means that map apply to geographic representations of other countries, such as Mars. But a simpler definition is that it's just any geographic image of the environment. So basically what a map aims to do is describe what is occurring or what is present on a given geographic location, given its location in space, giving us spatial context. However, a map can't show everything, and we present here the limitations of maps. Let's say we have a map here and we choose to add roads. So right now the map looks pretty normal. Okay, now let's add buildings. And this still looks like a generally regular map, but as we add elevation and now soil types, the map gets more and more busy and harder to read. You're probably seeing what I'm trying to get now, but if we keep adding more and more information, eventually we're just going to get a black canvas, where there's too much information to discern anything. This is where we present the importance of map abstraction, which is the idea that we only select the most important features for the purpose of the map to display. For example, let's look at what Google Maps shows for downtown Toronto. Feel free to pause the video and try to list out what is missing from the map and what is included. We can see that missing information such as zoning, elevation, soil type, certain road names, buildings are not included, but this information is generally not useful for the average user. Instead, information more relevant for the average Google Maps user, which helps with navigation, is included, such as main road names, subway stops, key points of interest, and pedestrian walkways. Another form to show map abstraction is the idea of mental maps, which are images of the environment which we have created and stored in our brains. If we try to make a map of our own neighborhood, what would we put in it? We'd probably put key roads, intersections, some buildings, but this is a very abstracted representation of our neighborhood, as it's only information that is relevant to us and getting us around our neighborhood. To end off the video, we're going to go over the 4 components that each map needs. Generally, not all maps need all of these components, but for the most part, when presenting a map, these 4 components are highly recommended to help the reader. The north arrow orients the reader spatially. The map legend describes what symbol tries to represent. The scale gives the reader a sense of the spatial scale of what's being shown, and the title brings it all together by telling us, the reader, the map's purpose and what it's trying to show or present. For example, for this election map of the US, a bad title is just US election map, and it doesn't really tell us anything about what year the election is or what type of subdivision is being shown on the map. We can fix this with the title 2016 election map by county, which is a good title, but we can improve it by trying to explain what the map is trying to show, which is the counties by presidential candidate victory, giving us the title US Counties by 2016 Presidential Candidate Victory, which is the preferred title here. Before we close off, we'll quickly go over the difference between large scale and small scale, which is important in describing the scale of the map. Large scale shows a smaller area, but features are shown larger in this version. For example, we can see here that San Diego is shown much larger in the large scale map on the left, compared to the small scale of the entire United States, where San Diego would probably be represented by only a point. A good tip to help you differentiate between the two is by taking the scale and making it into a fraction. So for example, if you take 1 to 200,000 here, change into a fraction, so it'd be now 1 over 200,000, and same with 1 to 80 million. So when we divide 1 by 80 million, we get a much smaller number compared to dividing 1 by 200,000, meaning that 1 to 80 million is this smaller scale map here. I hope this video was helpful, and in the next video we'll be going over the different types of maps.